Hey, good morning, everyone. Hello. Good morning, everyone. How's everybody? Anyone
Good
there?
morning, Professor. How are
Good morning.
you?
I'm good,
Hey, good morning,
Professor. How are
Jason.
you?
Good morning, Jared. Good morning, Jordan. All
Excuse me
right.
while I sign in.
What? You, what was happening while you were signing in?
I said, excuse me while I am
Oh,
signing
oh,
in.
no problem, no problem. I see 10 people in the collaborate, and let me quickly check how many people are there in today's forum. Looks like 9 people, right? Oh, 10, 10. So the numbers match 10 and 10 in uh, both sessions. Now, so
I'd like to apologize. I didn't put it according to how you uh, uh, want it because I was trying to sign in quickly and I forgot to change the font.
okay, no problem, no problem. As long as I see your names, um,
Not a problem. Sounds
yeah,
good.
as long as I can see your names here, right? That's what it. That's what matters. Okay, that's what counts. All righty. um, excuse me a second. All righty. So in our last class, we got started on the time value of money, and it's actually, as I said, it's nothing new because we've done this um, in the first topic, in the return on investment. We already got started on the compounding, and so we know that basically, okay, I might need to, okay, we know that. Um,
Was you about to put future value there?
yeah, I just had to resize the screen. Uh, we know that the future value is p times 1 plus r raised to n. And we also know there's so much. Okay, and we also talked about discounting. Discounting is the case where uh, we don't know p. In other words, if we don't know the principal, right? If you don't, and there are situations like that. I mean, you have certain target future value, right? Have a certain target future value, um, and then it can be. uh, then we also know. I mean, in case of compounding, future value is the unknown. In case of compounding, right? Future value is the unknown, but principal, rate, and time are all known. So we have like 4 variables, right? We have 4 variables. Uh, those 4 variables are FV, right? First, FV. and then P, and then R, and N. And each one of these could be the unknown. And if future value is the unknown, right, this is what we do. And if the principal is the unknown, right, then we solve it in reverse, right? It's future value and present value are reverse processes of each other. So that means, compounding and discounting are reverse processes of each other. So if we solve this equation for P, then P is unknown. P principal is the unknown. Then of course it's future value, right, over 1 plus R raised to N. Okay. So that's when the principal is the unknown. And also, this is called present value, right? If you're solving for principal, right, with the future value known, then this is called present value. Next question is then, so let's say, let's give it some numbers, and the numbers we have been using was, 10K. Not the. Ouch. My elbow. 10K for principal, right? And we gave, 10%. We assumed 10% for rate time 10 years. And first, future value was the unknown. But when we calculated future value, right, when we did this, according to this scenario, right, we got the future value was almost 26K, right? Remember? But let me just bring up the calculator and raise to 10. So that was almost 26K. I'm not gonna write down the almost 26K. Okay, but then there are situations that, when we don't know this, right? And if you exactly plug in 26 is the exact number is 25,937.43, right? If you plug in that number there and 1.1 raised to 10, and we will get exactly 10K. Now, next question is, so we have, next possible question.
How do we solve for n?
What?
Like, let's say if we don't know the time.
Yeah. We'll get there. But before that, we need to know how to solve for R, right? In other words,
In other words, rate.
right. So what if, of course, using the same scenario, using the same input values, right? We know R should be 10%, but how do we solve for it? Now, actually, we did this actually at the beginning of the semester. You may not remember, but in the house value example, right? If you in the house value example, we wanted to know the annualized growth rate, annualized return, or annualized growth rate of the uh, annualized growth rate of the house value. Now, annualized, and I explained at the time the difference between the growth rate and return, right? I explained the difference between the two. Um, and remember, hope I don't need to do this again, but I will. Okay, you see from what did I say? What did I say is the difference, was the difference between the return and growth rate. Growth rate is the return in scenario one. Return is the return in scenario two. What does that mean? Do you remember scenario one and scenario two? Does anyone remember scenario one and scenario two? Anybody? See, you forgot already. Nobody remembers the difference between scenario one and scenario two. I see 17 people.
I'm trying to remember. Hold on.
Okay. There are like 16 people in the collaborate. Let me just quickly check how many are. Okay, 16 here, right? 16. And then 16. Okay, numbers match. All right. I guess,
would the scenario be one would be the finding future value, or was it the something else?
no, it has not. Look, back back in the first topic one, right? I used, basically, I had to introduce the house value example as an example, right? For as an example for make distinguish between holding period return and annualized return, right? How to annualize the holding, as an example of how to annualize the holding period return, right? That was the purpose of this example. And in this example, think about it. If you buy a house, there can be two possibilities in terms of how you use this house, what you use this house for, right? Isn't it right? Number one, I mean, this is a common sense thing. Number one, you use this house just as your residence, right? It's your home, nothing more than that. But what's the other scenario? What's the other possibility?
I guess if you're renting the house out.
Yeah. You can rent the house out. Isn't that right? So in other words,
Correct.
right. How come Jason is the only one person could answer that? Was that Jason, right?
Yes, that's correct.
All righty, Jason. So you'll get 0.25 for that. Yeah, there are two possibilities when you buy a house. One, you just use it as your home, as your primary residence, and that's scenario one. Scenario two is where you rent it out. Now, in scenario one, there is no. In scenario two, there will be, if you rent it out, there will be rental income. Right? There will be rental income, which is the additional cash flow from owning this house. Why is it additional? Basically, there will be, capital gains or capital loss, right? Which is also the same
Sorry about
thing.
that. I just got booted.
Okay, you don't have to say that. I mean, if you, um, um, in scenario one, basically, there will be capital gains or capital loss because house value will change. Isn't that right? So that's what this
Yes.
column is for, capital gains. Capital gains. But in scenario two, there is not only capital gains, but also additional cash flow, which is, rental income, right? So think about it. In scenario one, we calculated the holding period return because you paid, when you bought it, you paid 150K, but when you sold it, it was 500K. Then during this 11 years, right? During this 11 years, um, the total capital gains is 350K, right? And then, so the holding period return will be 233% because you divide this by the capital gains, which is PT plus N minus PT, right? And you divide
Yes.
it by PT, right? So 233%. But in scenario two, right? In scenario two, you have not only capital gains, but also uh, the rental income. So the rental income, the additional cash flow, the rental income during this period, uh, total of that was, sum of all of that was 171K, 172K almost, right? I don't expect me to give you the read out the
Yeah.
number to you because it will take time. I'll just use the approximation, right? 172K, all right? Then obviously, there will be a difference in the holding period return, right? Under scenario two, the holding period return was 347, right? 347%. Now, if you annualize this uh, holding period return under scenario one, right? And I told you, you cannot simply divide by 11, right? You cannot simply divide it by 11. Why? Because there is a compounding going on. And basically, taking the average means, annualizing, right? Taking the average means, average growth rate means, taking the annual average growth rate. So let's say you find, annual growth rate, right? The capital gains alone between each year, 2016, 2015, was 20.77, and 0% between 2015, 2014, and so on. It's all like this, right? I don't have to show you how, but that's what annual. So then next question is, if we can't divide this by 11, can we just add them up and divide it by 11? And I said no. Why? Because that's simple average. That's just a simple average, and simple average doesn't work because because there's a compounding effect. You need to take geometric average, and I showed you how to find geometric average. And that's column E, which is annual growth rate of the house value only. Okay, but as I said in scenario 2, then the return cannot be simply this. Return cannot be simply growth rate of the house value, because you had rental income. So including the rental income, so therefore that's what happened. Annually the growth rate, the returns were like this. I mean, the difference between the return and growth rate is, I told you, as I already told you, growth rate is the return in scenario 1, right? Scenario 1, and return is the return in scenario 2 is the complete return, because it has both components, capital gains and additional income, right? But then again, it doesn't apply if you never rent it out. It doesn't apply. If you just used it as your primary residence, then the return is only the growth rate. Okay, so as we were talking about this, what was the concept that was brought up? Is geometric average. And then, so then think about it. This is exactly the geometric average under scenario 1, right? It's exactly geometric average under scenario 1. Why? Because you arrived at the future value from the present value, right? You arrive at the future value simply by even growth rate every year. Isn't that right? That even growth rate is the interest rate. Isn't that right? This interest rate is even every year. Every year is the same interest rate, right? Every year is the same interest rate, compounded by the same interest rate. I mean, so basically, this is exactly like, if you think about it, this is exactly like price of the house in 2005 and the price of the house in 2015, if you think about it. And N is 10 years, right? 10 years. I have so much jitter in this. This is this rubber tip pen. So I have a touch pen, but it never came with the batteries. It's a defective. I bought. And I bought it on eBay. The seller hasn't replied. It's supposed to come with the two small disc-shaped batteries, like the batteries that go into the watch, and one quadruple A battery. And never came with those things. So cannot use the the touch pen. I still use the this rubber tipped pen, and it's got a limitations in what it can do. So n is 10, and let's say we don't know r, right? We don't know, but this is constant growth, right? Interest rate is basically a constant growth rate, right? And it's not known. And this is like the price of the house in 2005. This is like the price of the house in 2015. Okay, then we are ready to solve for G, right? Or which is R in this case. I mean interest rate, but it is compound interest rate, right? So it goes by many different names. So then, how do you solve for that? I gave you at the time. I gave you the formula already. I gave you the formula. The formula is future value over P raised to 1 over n minus 1. Okay, but at the time, no explanation why. I mean, in most classes, especially this is Finance 100, right? Because this is Finance 100. At BMCC, this is the number, course number is 100. So it's supposed to be like intro level. It's not at all, because this is like 3,000 level course in Baruch or in any four-year schools. This is like 3,000 level. Why? You can't take this actually, without taking without having met the prerequisites, right? In 4 years programs, you have to have met the prerequisites, which are macroeconomics, macro 1, micro 1, and macro 1, and then math, certain level of math. So only in your, so that's why this course is 300 level course. But at BMCC, we cannot do that, because if I wait for the students to have met all those prerequisites, then there's no way they can do this within the 2 years, within 2-year time frame. I mean, if you were to take this in the 3rd year, then there's no way you can do it in, people will have simply completed 60 credits in, and this type of finance program cannot even exist, because the students will have completed 60 credits only in liberal arts, and will try to will have within 2-year time frame, 2 to 3 year time frame, and will have transferred out. So this course cannot wait for the students to have completed all the prerequisites. And if you have ideally met all those prerequisites, then it will be a lot easier to teach this course. But since we don't have the luxury of time, right? Nobody hangs around at BMCC for 3 years, 4 years, 5 years just to take this course. And even after this, then there is Finance 230, Finance 250, Finance 300. So we have very loose. I mean, we can't help but having a very loose prerequisite, having very loose prerequisites, or very loose prerequisite requirement. So usually in this course, nobody, and even in 4-year schools, nobody explains how they got to this formula. In other words, how this came about, right? This is only the conclusion, but what is the process leading to this conclusion? What's the process? I mean, through what process right? And I'm the kind of person who cannot live without explaining the process. It's just me. I mean, it's my pet peeve. If I don't explain how we arrive at this, right? How this formula is arrived at. I mean, what process brought us to this end result, right? Just giving you the end result is meaningless because that's just like, throwing it at you, the formulas at you, and memorize, right? Memorization cannot last long because you may memorize all these formulas for this semester, but after this semester is over, then you will forget. You will forget almost 100%, right? So it's not the end result that's important. It's the process that's important. Process leading to this result, to this end result, right? So and because of that, I gave you the process. How I gave you the process for all of these formulas. For future value compounding, how we arrive at this formula, and for present value, how we arrive at this formula. I gave you the process all the time. So then let's think about what is the process for uh, the growth rate, right? Okay, so my mouse is stuck. Oh, but before doing that, let's see the time. Before going to, let's do this Excel exercise. I want you to download. I mean, this file is there. It's just a matter of looking, but a lot of students don't bother to do that, and that's clearly a problem. And in every topic folder, I clearly state, please download the above files. Should I say the files above? I think the files above is the correct way of saying it. And use them with the videos. It is imperative that you use this Excel file to replicate the algebraic models demonstrated in the video. So then you must download this. This is not Excel file. This is clearly Excel file. But this is PDF file, and this one is it says Excel XLSX. That's the extension of Excel file, right? So you should have downloaded it and used it as you're watching the main lecture videos. If you didn't, download it now, please. Download it, and once you download it, and it may not be this page. I mean, this worksheet is the first one. When you download it, it may be here, or it may be here. I mean, I don't know. It may be here, or you got to look at the bottom tab because there are multiple bottom tabs, and you have to select the correct one, right? Each bottom tab is for different worksheets. So you must select the right one. So has everyone downloaded this file?
I have.
Okay, if you have, then find the right worksheet and delete all the highlighted cells. Delete all the highlighted cells. Okay, and if you have highlighted deleted all the highlights, now let's start with the first example, and this example is quite obvious. And make sure make sure your data matches my data. Is your principal 10,000? If it isn't, please change it to 10,000. And as you change it to 10,000, you will see this will automatically adjust because, I already entered equals A2 there. So whatever is in A2, this will automatically be equal to that. Is your APR 10%? If it is not, change it to 10%. APR is, of course, annual percentage rate. So that's the interest rate. Is your time 10 years? If not, please change it to 10 years. M, I will get to that later, but make sure the M is 1 in row 2, and make sure it is 4 in row 3. Okay? All righty, so everyone is, and this is our example exactly, isn't that right? Our example, because our example is that your principal is 10,000, 10K, right? APR, your rate is 10%, time 10 years. Isn't that right? So everyone has the matching data. Please confirm. Everyone has the matching data. Christian, do you have the matching data? Christian, are you there? You have the matching data?
Yeah.
Okay, good. Cora, do you have the matching data? Cora, are you there, Cora?
Sorry about that.
No problem. So you got booted out again, huh? All righty, Cora, are you there? I will have to assume you're not there. Felicia, are you there, Felicia? Felicia, are you there? I'll have to assume you're not there. Grayson, are you there, Grayson? Jared, are you there? Jared?
Yeah, I'm here. Sorry.
Okay, you're there. Good. You have the matching data.
Yeah, I updated it.
Okay, great. And Jesus, are you there, Jesus? Jesus, are you there? I'll have to assume you're not there. Okay. If you don't respond immediately, I'll have to assume you're not there. Okay. Jordan, are you there?
Yeah, I'm here, Professor.
Okay, Jordan. So you have the matching data?
Yeah, I have everything.
Yeah. Okay, good. Justin, are you there? Justin?
Yeah, I'm here, Professor.
Okay, you have the matching data?
Yeah.
Okay, Kenny, are you there, Kenny? Kenny, do you have the matching data? No, you're not there. Okay, Michelle, are you there? Michelle?
I'm here, Professor.
Okay, good. You have the matching data?
Yes, I do.
Okay, good. Natasha, are you there, Natasha?
I'm here, Professor.
Yeah, you have the matching data?
Yes, I have it.
Okay, Nolvia, you too? You have the matching data?
Yes.
Okay,
Professor.
great. Great. CFAT, you have the matching data?
Yes, Professor.
Okay, great. Now we can go ahead. So, we did this calculation with the calculator, but using the calculator, if you use the calculator, you have to enter the data every time. Okay, but here I'm gonna by using Excel, you don't have to do that. You don't have to enter the formula every time. As long as you have data filled in, initial input data, you have to manually fill it in or download it. Unless you can download it, you will have to manually enter it there. But that's only the data. As long as the data is filled in, the rest of them is simple, and you can replicate the result over and over. Now, first, principal is there, A2, so you got to always start with the equal sign, because that's exactly what the formula, like the formula, because future value is equal to. Isn't that right? So we are doing exactly that. Future value is equal to principal, right? Which is in A2. And again, you don't have to, you don't type in A2. You don't manually type in A2. You can just, you can just click in. You can click in A2, right? Okay, what I'm saying is that you can use your mouse. Using your mouse, you can just, click this cell, right? Use your mouse, click the cell, and the data will go in there. So that's A2. And then times, of course, times you will have to enter manually. Times and open parenthesis, 1 plus 10%. You can click it in, right? Raised to 10 years. Okay, there you go. Then we get exactly 25,937, right? So this way, and then next, then what is that M? M is compounding frequency per year. Okay, M is compounding frequency per year. Now think about it. We have been assuming that compounding happens only once a year. No, compounding doesn't have to be only annual. It can be quarterly, it can be monthly, it can be semi-annually, semi-annual, or semi-annual. It can be monthly, it can be, even weekly, it can be even by daily, it can be even by the hour, or, theoretically, I mean, nobody uses, they don't use, hourly compounding or in reality because it's too, it will be too cumbersome. But they use up to daily compounding. So what that means is how many compoundings per year? That's called compounding frequency because it's, literally the name is compounding frequency per year. Compounding frequency per year. So 1 means once a year. So it's annual compounding. If it is 4, that means quarterly compounding. And then down here, look, quarterly, 2, that means semi-annually, twice a year. So semi-annually, twice a year, right? Twice a year, not every 2 years, right? Because some students confuse between semi-annual and biennial. Biennial is, or biannual or biennial, B-I-E-N-I-A-L. Biennial means, every 2 years, right? Every other. But, some students think, every 6 months is, if it is semi-annual, some students think, 6, M is 6. No. Think about it. That's ridiculous. If M is 6, that means compounding happens every 2 months. Isn't that right? If compounding frequency is 6 times a year, that means every 2 months. So every 6 months doesn't mean 6 times a year. Every 6 months means 2 times a year, right? So it has to be 2. 12, if the compounding frequency is 12, then that means, monthly. Also semi-annual and then quarterly, right? So if we have different compounding frequency, then think about it. If, like, quarterly compounding, then what's going to be the interest rate that applies every quarter? What will be the interest rate that applies every quarter? Think about it. It's annually 10%, right? So quarterly, it will have to be 1/4 of that. You divide 10% by 4, 10
All right.
would be 2.5% every quarter, right? But you don't have to do that calculation yourself. You can leave it to the computer. You can leave it to the Excel. All you need to do is, yeah, I'm not, look, I'm going to do it here. Why? You might wonder, that's annual. Why do you do it there? Look, first of all, I can simply adjust tweak the formula here and just drag it down, and it will apply. Everything will, automatically adjust. For example, M is 1, right? Compounding is once a year. So there's no change because you're dividing 10% by 1. It will still be 10%. So there's no harm, right? But if I copy this formula to row 3, then the change will take effect. And then how many compoundings happen during a year? Well, compounding happens only once a year, so there's no change. So you simply multiply it by D2, which is 1, so it's not going to change. But think about it. If the compounding is 4 times a year, right, you will have to make that adjustment here. In other words, without manually adjusting it, if you have made that adjustment here, no change in this result, but you can simply drag it down. By dragging down, that means you're copying. Look, there are 2 ways you can copy. One, you can bring the cursor, you can move your cursor to this lower right corner, which is also called southeast corner of the selected cell. And then the cursor turns to a thin black cross. And we did this because I don't need to re-explain this, because when we did this example, right? Right? I did all that, all I need to do was, just dragging it down, right? Drag it down, the formula gets copied, right? All of this, I just, drag it down, formula gets copied, right? I think I should move this. Right? We did that already, so I don't think we need to explain. I need to do that again. So here, then, look, since the formula is the formula is the one that was copied, okay? It's not the number that gets copied. It will never copy the number. Because you have to, it's called the surface structure. I mean, on the surface, it's only number. But in the behind it, in the deep structure, right, it's the formula. And you need to look at the formula. You need to look in the deep structure, not the surface, right? You must not be a superficial person, right? You shouldn't be a superficial person. And it's not only for, judging people, but also, this must be part of it must run in your bloodstream. It must be part of your second nature. It must be your second nature. So in everything, you should look at something behind or something under the surface. And this is what's under the surface. And you need to look at that, not the number, right? You must always, right, search for the structure, right, under it. So the formula has been copied and it automatically adjusts to the new data set. So here, A3 is still the same principle. 10%, B3 is still 10%, but B3 divided by D3 will automatically make it 2.5%, right? And C3, which is 10 years, over 10 years, how many compoundings will happen? 40 times, 40 compoundings, right? 40 compoundings. Why? Because it's 4 times a year. It's quarterly, 4 times a year. And without manually entering 40 there, this will automatically take care of that without manually entering, right? Okay, there you go. And we can do these problems also in the same way, right? For example, it's, A times 1 plus APR divided by M raised to, right? T times N. And then you can also simply, drag it down. But then, that's not what we want to do here. Now, if you think about it, this is how I, this is how I did it. This is the tweaked formula. I mean, I tweaked the formula a little, right? This is how I tweaked it. But then, dividing APR by M, right? If you divide APR by N, what is that called? That's called the periodic rate. It's called the periodic rate. And periodic rate is the actual rate that applies, right? That applies to compounding. So we don't have to throw away the symbol R, right? Because that is the periodic rate. Depending on the compounding frequency, the periodic rate will vary, right? And also N times T or T times N, that's the actual number of compounding. So actual number of compounding is N, right? We have been consistently all this time, we have been using that notation, right? N, R, and N. So we don't have to ditch those symbols. We can still utilize those symbols. So if we use so what is R and what is N? R is the periodic rate. N is the actual number of compounding. Actual number of compounding. So then, oops, my computer is acting up. So, then let's find periodic rate. Let's find R and N. R is, so all you need to do is, by definition, R is APR divided by M. N is then T times N. Okay, so then when you have R and N, then all you need to do is we can go back to the simpler version. simpler version of the formula, right? So then P times 1 plus R raised to N. Okay, we can return to the simpler version. Okay. In other words, if we use this formula, right, then the formula gets more complicated. Formula gets more complicated, right? But if we use this version, the formula is simpler, right? But we just need to make adjustment. We just need to make adjustments to R and N outside the formula. We just need to add in just two more columns, right? And then once you are done, you can easily just copy and drag it down for other problems, right? And then just drag it down for the future value, okay? So
Professor, isn't there a much quicker way than just using the formula? Like, isn't there like a function, like finance function?
yeah, but look, this one is actually this one is much this one is better. This one is much better because if you use the Excel's built-in function, right? Look, you can use that, but look, for example, here, you will still need a data table. You will have to have this data table, right? And why separately do that? For example, if you use Excel's built-in function, you never your
All right.
built-in function is a black box. In other words, it's just a calculator. You will have to enter the rate, and look, it's better to enter this rate. I mean, if it is not, look, if it is not like this, I mean, for example, suppose you are doing it here and using Excel's, built-in function. Rate, what are you going to put in? Are you going to put in 10%? Huh? Are you going to put in 10%?
No, you wouldn't. You wouldn't if it's
Yeah, quarterly compounding, you wouldn't. You have to make adjustment here. You wouldn't put in this 10%, but you would put in like B3 divided by D3, right?
Okay.
You'll have to enter it like that, right? And then N periods, you cannot put in just 10 because we know it's going to be 40 periods, right? Then you will also need to make that adjustment here. Okay, which is not a bad. No payment. Present value, you will need to enter this as negative, right? Because
correct.
The financial calculator will work only with negative cash outflow and positive cash inflow, because this is a future value, which will be your cash inflow in the future, right? I mean, if you are making this deposit every if you're making this deposit at time 0, then this future value will be your cash inflow. The present principal will be your cash outflow. Or if you're the lender, this is your cash, if you're the lender. But if you are the borrower, this is your cash inflow, and this will be your cash outflow. So depending on whether you are a lender or borrower, what becomes the cash outflow and what becomes cash inflow will change. Then, it will be annoying. I mean, it's not a big deal, but by doing this, then hit OK, and you'll have the same result. But then again, looking at this, you don't know what you did. Looking at this, you don't know what you did. I mean, you can tell, that's, that must be 2.5%. I entered rate, and then I entered N, and then I entered PV. But you can also, there's like a what do you call it, subtitle. There's a subtitle that's floating right below it, so you can guide yourself. But it doesn't, mathematically you don't know what is going on there. It's just a black box. You're just entering data. You're just entering input data, and you don't know the mechanism, right? So that's why I don't want you to use Excel's built-in function, okay? Because it doesn't you won't be cognizant of the mechanism that's going on. And what's important is the mechanism. If you do it this way, you know the mechanism, right? Math is mechanism.
That makes a lot of sense. You understand the mechanism.
Yeah, math is the mechanism, and it's the point is the mechanism, not the just punching in the data into the calculator, right? So everyone got the same result. Let me know. Did everyone get the same result?
I pretty much did.
Okay, good, good. How about everybody else? Oh God, I'm raising my voice and my head is, it's almost
I
like my
did.
head is banging.
I did.
All righty,
Professor.
all righty. Okay, don't make me raise my voice because my brain is like banging in my cranium. When my voice is raised, it's so exhausting and so tiring. All righty, so if you got the same result, then we're gonna have to take a 10-minute break. It's 12:05, so we'll take a 10-minute break and reconvene at 12:15. Okay, all righty. All right, we're back. We're back. So next. Okay, now, so we know basically um, how to find future value and present value. In other words, how to do compounding and discounting with compounding frequency greater than one, right? In other words, with multiple period compounding, right? Now then, let's think about how we can how we arrive at this formula. This is basically the formula to find the rate, okay? And in this case, it's only the growth rate, not the return in scenario two. Of course, we can do that too, but in our example, it's only between future value and the present value. It's straightforward. It's basically a very straightforward compounding situation. In other words, there's no additional cash flow. It's all due to the future value is the result of all capital gains, all growth of the capital. So this type of rate is also called CAGR, but this is also what does that mean? What does that stand for? What does CAGR stand for? There's so much jitter. Let me.
Cash advance growth rate.
No. Compounded annual growth rate. Okay. I mean, if it is, I mean, what's cash advance? I mean, what? There's no. The term doesn't, cash advance. I mean, where is the cash advance in this case? I mean,
I meant to say compound annual, but okay.
Yeah. But then as an acronym, it has to mean it has to make sense, and compounded annual growth rate makes sense because we're talking about the compound rate. But then annual, I have a problem with that because if it is not annual, it cannot be, it must be annual only. I mean, it can be quarterly, it can be monthly, it can be, even weekly, daily, it can apply. So,
Can we say average?
no.
Okay.
It's compounded annual growth rate, but the way they use this term is mainly for annual growth rate. So actually, this is not the right term to generalize it, right? For generalization, it's just better to call it just compounded growth rate. Okay, compounded growth rate, not annual, right? So I wouldn't even,
So it would be CGR, compounded growth rate.
yeah. If you want to use an acronym, right? But I would just use, G, growth rate, right? Growth rate. But anyway, let's think about.
That makes
Let's think about the process. In other words, the steps of derivation. First of all, it all starts. I mean, think about it. How do we arrive at that? Basically, we have to start from an initial equation. An initial equation is always the starting point is
EQ value principal times 1 minus
yes,
plus 4 with over not to the nth power, or raised
Yeah.
to the n.
Yeah, raised to the nth power, right? P times 1 plus r raised to the nth power, right? Raised to n. Now then, because the our and because our concern is r, right? We need to isolate this, but there's no way you can directly isolate r. Why? First of all, it's in the parenthesis, right? It's enclosed. It's enclosed in the parenthesis, and then there's a lock. The lock, the padlock, the exponent. So the thing is, first you will need to, but first you will need to isolate, because this is like, you will need to isolate this term. In other words, this is like z equals x times y structure, isn't it right? It's like z equals x times y format, isn't it?
Yes.
And since y is the term that contains our r, you want to isolate y first. To isolate y, of course we know we will need to then divide both sides by x, right? Then the left-hand side will be z over y, z over x. I'm sorry, z over x.
Then the other side will be
Just y.
y over.
Right? Y,
Right.
just y isolated, right? Uh, the right-hand side, this is left-hand side, and this is right-hand side. Right-hand side will be just y. So just like that, we will need to isolate. We will need to isolate this term first, right? We will need to isolate y first. So what do you do? Then you will need to, right? You will need to, the left-hand side will be fb over p, right? The left-hand side will be fv over p, and the right-hand side will be 1 plus r raised to n. This is, I just hate this jitter. Okay, and then next thing is, because we need to we need to open up this padlock. In other words, we need to remove this padlock. How do we remove the padlock? In other words, because it's an exponent, right? We need to understand the properties of exponent, right? First of all, instead of writing, I want to use my yes. This file is there. This is one of those. This is the first file, right? In the topics folder. And you must use it, as instructed, you must use it. So basically, what is that? So one of the properties of the exponents is that now we know x squared. If y is x squared, right? If y is x squared, if x squared is y, then if you take the square root, right? If you take the square root, then if you take the square root, then it will become x, right? You see, as much as I try not to use, this is called power function, it's y equals x squared. But, then if you take the square root of x and the square root of x squared, you think this is square root. Yes, but, it's a simplified form. Actually, square root must have 2 here. Okay? Why? Because there isn't only square root. There is third root or cubic root, or fourth root, fifth root, sixth root. In other words, if y is a number that is cubed result of x, cubed result of x, then to take the cubic root or the third root of x cubed, you'll have to take the third root or third radical, cubic root or third radical. Okay, if it is fourth root, again, if it is x to the nth power, then you will have to take the nth radical or nth root of x to the n. Okay, now, but then another way of writing x squared, square root, another way of writing square root is raising to half power, raising x squared to the half power. Okay. Raising x squared to the half power. And it's also the same thing. Taking the third root is the same thing as raising whatever is this thing, right? You raise it to the 1/3, right? That means, if it is x to the n, if you want to take the nth radical, nth root of the number, you'll have to, raise it to the 1 over n. Okay, so if y is x to the n, right, then raising x to the n, taking the nth radical of x to the n, it's the same thing. We write it as x to the n raised to the nth power. And we know some of the properties of exponents, right? Anything raised to 0 is 1. Anything raised to 0 is 1, as long as the base is not 0. And negative power, negative exponent, is the reciprocal. You understand? I've shown you, I've been using, like, look, x to negative 2 is 1 over x squared. Okay, and then also there are many properties. One of the properties is, one of the properties is this power of power, right? X raised to B raised to C is A to B times C, right? Whereas, A to the B, A raised to the B times A raised to the C is A raised to B plus C. I mean, let's do a simple, very simple experiment. Now think about it. 2 squared times 2 to the third power. What's it going to be? 2 to the 2 squared is 4, right? 2 cubed is 8. Then it's 32. What is 32? 32 is 2 to the 5th power. Isn't it right? 32 is 2 to the 5th power. So what was that? That is exactly 2 to the 2nd power plus the 3rd power. Isn't that right? It's not a very difficult thing. Yeah. It didn't come out of nowhere. It's just, and then another example. Now, power of the power rule. So let's try 2 squared raised to the 3rd power. And what's that? We already know 2 squared is 4 to the 3rd power, right? 64. 4 times 4 times, it's 64 because it's 4 times 4 times 4, right? And what is 64? It's 2 to the 6th power. Isn't that right? 2 times 2 times, you do that, 2 times, 2 times 2 times 2 times, you do that 6 times, and then you'll see it is, which is what? Okay, which is what? Which is, 2 to the 2nd power times 2 to the 2nd power times 3rd power, right? Isn't that right? So that rule is, easily verified. Okay, that rule is easily verified. Also, the rule, this, raising to 0, why is it 1? Think about it. Suppose we have x to a, x raised to the a, times x raised to the negative a, right? Then what is it? Same base, so using the this property, right? Product of power, right? Using this property, then it's going to be x raised to a minus a, right? Now, x to the a minus a is what? X to the 0. X to the 0. Isn't that right? Also, it's the same thing as x to the a times, what is this? X to the negative a is 1 over x to the a. If it is, x to the a times 1 over x to the a, then what happens? They cancel out. They cancel out. So that's why, if they cancel out, it becomes 1. That's why x to the 0 is 1. Anything raised to 0 is 1. You understand? This is all the review.
Yes.
Okay. I don't have time for throwing in number and do that, but you try that. And then using this rule, and again, think about it. Using the product of product, right? So here, let's think about that one, right? Oh no. And let's think about this, right? So we know the product rule. So power of power, right? X to the n raised to 1 over n is then x to the n times 1 over n. Now what's going to happen? They cancel out. This becomes x. In other words, that's how you can turn x to the n to simply x. Now this becomes, then think about it. This becomes x, but originally what was on the right hand side of the equation? This is all left side of the equation. Right hand side of the equation was y. Isn't that right? All that happened so far was just the left hand side, but nothing, we haven't shown anything on the right hand side. But think about it. If an equation is something, equation is something with the left hand side and the right hand side equal to each other. That means if something is done to the left hand side, you must do the same thing to the right hand side. So what we did to the left hand side is raising that to 1 over n. Then we have to do the same thing to the right hand side for the equal sign to hold, or for the equation to hold. You understand? So then what should happen to the right hand side is y raised to 1 over n. Okay? Do you get it? So then think about it. If you understand this, then let's go back to the original question. So we have isolated this term. We have isolated this term. And then because of the padlock, we can't do anything. So we got to get rid of that padlock. So what do? So we'll have to, using the power of the power, we'll have to take the nth root or nth radical of this term. If you take the nth radical, that means this thing raised to 1 over n. Isn't that right? Then when you raise it to 1 over n, right, to the right hand side, you need to do the same thing to the left hand side. Isn't that right? You'll need to do the same thing to the left hand side. So In other words, that means you need to the left-hand side must also be raised to 1 over n. Now, the right-hand side will be free now because n times 1 over n will cancel out each other. So the right-hand side will be freed. It will be 1 plus r. Then, what are we solving for here? What are we trying to solve for here? Anyone? What are we trying to solve for here? What is our unknown? Isn't it right in your face? Isn't r the unknown? It's encircled in red.
The growth rate.
Yes, you're right. You're right. The growth rate. So then left-hand side is this. Right-hand side is this, but we want to isolate r only. So what do we need to do? Then we'll have to subtract 1 from both sides or transpose 1 to the other side. You understand? Eventually, so what needs to happen? So in other words, isolating only r, right? So we isolate r, then we subtract 1 from both sides, so the right-hand side will become only r. Now the right-hand side is the left-hand side now, and from the other side, the left-hand side, which is now the right-hand side, you subtract 1. And then think about it. This is exactly how we arrive at how we arrived at this. In other words, this is the result. All the textbooks and most other professors, either here at VMCC or at Baruch, they will only tell you this. They will only give you the result and tell you to memorize. Or even worse, just plug in the number into the Excel's calculator. Then just plugging in the number into Excel's calculator or any financial calculator, it's just making everyone dumber. Why? Because then you don't know the process. You don't know the mechanism. You just you just punch in the number, right? It just it turns into a data entry personnel. You just input the data without knowing the mechanism. And that's what I don't want you to become. Data entry can be done by anybody. What's important is the programming. What's important is knowing how to program it, knowing the mechanism, structural mechanism, right? This is why I want you to use the formula, not the Excel's built-in function. And see, so we arrived, finally, at that formula. In other words, it's not important to know that formula. What's important is to understand how that formula was derived, right? That's what's more important, because that's your really logical reasoning ability. Okay? Alrighty, so we're out of time, and so that's it for today. Weeks almost like 6 minutes past the hour, so you guys owe me 6 minutes next time. Okay, alrighty. So any questions so far? No,
I think everything was explained. Thank you very much.
Okay, great. If you have any questions,
Thank you,
then since
Professor.
we're out of time. All right, you're welcome.
Have a good one,
Thank
Professor.
All righty, I will see you guys next Monday. don't forget there's an exam, right? Midterm due this weekend. All right. I'll stop sharing, stop recording, and sign.